Assalamu alaikum. Welcome to semester 403, the summer course, and welcome to the concepts of programming languages course, CS 472, CS 307, and my name is Munzen. I will be your instructor during this semester, inshallah, and I hope that it's going to be an easygoing and successful semester. Before I start teaching chapter 1 of this course, I would like to take you a few minutes through the course materials, syllabus, course information, and schedule and timing of this class. So first, if you go to your blackboard, which I would recommend that you check it every time to see what's new. This course, which is basically for most students, is CS 472 with one student added here, and the course materials have been uploaded to this course. Here in the announcement you will see this announcement in which I have welcomed you to this course and showed you that there are 3 days, Sundays, Tuesdays and Thursdays, period 4 and 5, and some of the lectures will be with recorded videos, and some of the lectures will be live sessions, and but mostly the lectures will be recorded. The live sessions may be to check your attendance and follow up of this course, and also answer your questions if you have any questions. So, but our first lecture will be live session, so that we can set some information for you and notifications, and we'll be able to understand what you need to do for this course. All right, so please read this welcome message, and I have here also in the course objectives, I have the course syllabus downloaded. Please, this course syllabus is have been updated to include 8 weeks only. So this course requires that you pass data structure course, and the description of this course is we're going to cover the syntax and semantics, data types, control structures, subprograms, exception handling, and also functional logic and object-oriented and concurrent constructs. Of course, the objectives is to interpret the principles of programming language design and control structures, and also for you to become familiar with the different schools of paradigm of programming languages, like functional programming and logic programming, and also to learn how to specify some syntax for some languages and develop some understanding of programming language implementation, especially for those that have impact design on the system programming and software applications. The book, I'm not sure if I have an online digital copy, but I will try to find one and upload it to your blackboard. But the book, if you try to find it, is called Concept Programming Languages, edition 9, written by Robert Sebesta, and published by Pearson. Alright, this course, the assessment method is going to be like any other course, like any other semester, in which we have like 20% for quizzes, and assignment for 20%, midterm 20%, and final is 40%. The course outline will be the Chapter 1. We're going to be covered in week 1. Chapter 2 is going to be covered in week 2. Chapter 3 is going to be covered in week 3. Also, in week 3, we're going to conduct the first quiz 1. And in week 4, we're going to have the midterm exam, and also Chapter 5 will be covered in that week. Chapter 6, however, and 7 will be covered in week 5. Then in week 6 we'll cover chapter 8 and 9 together. We're going to have our also second quiz. In the last week before the exams, week 7, we're going to have 2 chapters. That's chapter 9 and chapter 14. And of course also assignment 2 is going to be in this week 7. And the final exam will be given in week 8, which is the last week. For assignment 1 is going to be given between week 4 and 5 in this area, but it will be announced. Alright, this is the syllabus. Please download it and go over it one more time. For the schedule for this course, we will meet, as you could see here, on Sunday, period 4-5, Tuesday 4-5, and Thursday 4-5. Okay. I have one student that in the other section that have been moved to this section. Now we all going to be in one section, which is 472. But the same timing, 4-5, 4-5, 4-5, Sunday, Tuesday, and Thursday. When we meet in the timing, we meet through virtual classroom. So click in virtual classroom, and then you will be able to click on course, and then click on join course to join the course in that specified time for the course. And that's it. The week 1 already here and posted, and week 2 chapter also posted. So we're gonna go ahead and start our first chapter, and we will meet you in the class time to discuss any information that has not been covered. Alright, concepts of programming languages. So what is the course is all about? This concept programming language, this course is actually all theoretical. There is no practical on it, because it is a generic course. The objective is to give you a flavor of different languages, the historical backgrounds and the evolution, implementation and design and stuff like that. There's going to be a lot of theory involved in this course. So chapter 1 starts with the reasons for studying concept programming languages. What are the reasons for studying programming languages? Then also we will talk about programming domains and language evolution criteria, and also we'll cover influence on language design and language categories and language design trade-offs. Also we'll cover implementation methods and programming environment. So let us start now with the reasons for studying concept programming language. Why do we study the concepts of programming languages? In other words, why are we taking this course as a computer science programming student? Why are you taking this course? There are many reasons to study the concept programming languages. First, increased ability to express ideas. So your ability to express ideas in programming sense is going to be increased. Your problem solving skills and abilities will be widened. Also, improved background for choosing appropriate languages. A lot of people would like to think about why do we choose a language to do specific application rather than choosing another language. So what is good about this language compared to another language? Why this language is chosen to do specific program rather than this language? There are a lot of questions that you have been asking. So of course, as a programming student, you'd like to know why. So this studying the concept programming language will improve your background for choosing such appropriate language for those applications. Also, increased ability to learn new languages. Your ability to learn new language will be definitely increased by studying the concepts of programming languages, because you're going to actually cover a lot of things, starting from the syntax, the logic, the problem solving techniques, a lot of different things that you will learn through the concept programming language that will increase your ability to learn a new language. For example, studying C programming language, C, not C++, just C. Now people are asking, why are we studying C programming language right now while it is not used? It is not used in commercial applications. And the answer, simply, if you study C programming language and you understand it better, you understand it well, then you will be able to learn any other language like C++, C#, PHP and stuff like that, because they are similar syntax, so it will help your abilities to study other languages. Also, better understanding of significance of implementation. The implementation of the language itself, you will be able to understand the implementation procedures and platforms. In which platform are you going to implement this language? And also, one of the reasons for studying concept programming language is going to be better use of languages that are already known, and you will be proficient in the language that you already know, you already studied, you already use, and you already practiced. You're going to be perfect them. You're going to perfect them. You're going to actually be better than before. And also, studying the concept programming languages will be good for overall advancement of computing itself. So these are the reasons for studying programming languages. Let us move to the programming paradigms and discuss the 5 different domains for programming languages. So in programming domains, we have 5 programming domains. So all programming languages are covering these 5 areas: scientific application, business applications, artificial intelligence, systems programming, and web software. In scientific applications, there is a large number of different computations that are done in programming languages, and use of arrays also introduced in scientific applications. And all these languages like C++, like Java, Fortran, since Fortran and Algol 60, which is the first version of language, they introduce such scientific applications, scientific applications that have been created using mathematics, using computation, are one of the programming domains. Also, business applications. Business application began back in 1950s, and since the development of COBOL, and also there is a language called Lotus Notes. Lotus Notes that is produced in 1960s as well. It is these applications are well known of producing reports and using decimals and characters, and but the famous application now for this business application is called COBOL. SAP also is one of those languages that are now used in some companies. Artificial intelligence is using symbols rather than using numbers, and the use of linked list. It is not a new one. It is introduced back in the Lisp programming language in 1960s, and also through the application prepared using Prolog languages in 1970s. Artificial intelligence now is actually the prominent applications in this era, or in this time. Artificial intelligence is dominant, and also systems programming. System programming are development of system programming means development of operating systems like Windows and Apple, Mac, and all this. System programming, system applications are created using some programming languages. Like, for example, C programming language has been developed basically to create Unix operating system back in 1970s, before becoming an application that before becoming a language that people use for applications. Web software, which is relatively new, which is electronic collection of languages using markup language like hypertext markup language, HTML, or scripting like JavaScripting or PHP or other scripting language like Python and stuff like that. They are all used in what we call software, web software applications. So the domains are 5 domains again: scientific applications, business applications, artificial intelligence, system programming, and web software. The language evaluation criteria are four criteria for evaluation criteria. Evaluation criteria means how to evaluate the language in terms of what? In terms of readability, writability, reliability, and cost. In readability, they're talking about the ease with which programs can be read and understood. So how easy the program that are created can be read and understood. This is talk about readability. In writability, they talk about the ease with which language can be used to create programs. How easy this language can be used to create other programs or applications. For reliability, the conference to specifications like performance of specific specification that are used in some applications in order to create them. So the language can be evaluated in terms of performing specific features that are needed by the software or not. Also, a language can be evaluated by cost. There is a lot of cost involved. The ultimate total cost includes cost of training programmers, cost of writing programs, cost of compiling programs, cost of executing programs, and also cost of testing the programs and see how well they work. And here there are some details about readability, like overall simplicity. Overall simplicity means you talk about a manageable set of features and concepts, and also there should be minimal features multiplicity and operator overloading, not using the operator for the same purpose again. So this operator overloading should be minimized. Also in data types, there should be adequate predefined data types in the language. Data types like for character, string, floating point, and decimals, real numbers, and so forth. Also, the readability involves syntax considerations, because they should be flexible composition and special words and methods of forming compound statements. There should be some what's called self-descriptive constructs and meaningful keywords to use in the language syntax. And for writability, simplicity and orthogonality means that there should be few constructs and a small number of primitive and a small set of rules for combining these constructs. And support for abstraction means the ability to define and use complex structures or operations in ways that allow details to be ignored. So what you mean to support abstraction means you ignore the details and focus in the big picture, in the big purpose of the language. Expressivity means a set of relatively convenient ways for specifying operations, like strings and number of operators and predefined functions that define a specific purpose. Functions should be written in order to execute a specific task. And for reliability, we're going to have like three different points, which is type checking, exception handling, and aliasing, and also readability and writability. For type checking means testing for type errors, for data type errors, to check to see if it has errors or not. Exception handling, this is intercept runtime errors and take some correction measures in case there were some errors. Aliasing means talk about the presence of two or more distinct referencing methods for the same memory location. So aliasing means the same thing is used for to describe something that has been like twinning, what we call twinning, which is two or more methods for the same memory location are used to store the same value. Readability and writability means a language that does not support a natural way of expressing an algorithm will require the use of what is called unnatural approach and reduced reliability, because a language should be reliable in which both readability and writability are maintained. And for the cost, we talk about the training programming people or programmers to use the language. We have to spend some money on them. Also, cost of writing programs that are very close to particular applications. Also, the cost of executing programs and maintaining programs. Maintaining programs means editing and correcting the errors, fixing them, and also testing them, and correcting the runtime errors as well. And there are also other evaluation criteria like portability, generality, and definedness. That means in portability means the ease with which programs can be moved from one implementation to another, or from one platform to another, or from one computer system to another. With generality, we mean the applicability to a wide range of applications. How can we apply this to wide area or wide range of different applications that can cover them? Well, definedness, we talk about the completeness and precision of the language official definition that have been developed in order to handle such a task. What influences that has been done on language design? There is a lot of influences that affected language design. The first one is computer architecture. The computer architecture that had been developed early in 1960s, maybe before that. It is called the von Neumann architecture. I will talk about von Neumann architecture in a few minutes, which is architecture that you have been referenced, or you have been exposed to it through your first course of computer skills, in which you will know that a computer has three different components: input, and then processing, and output. So the computer architecture itself has been influenced by such the languages that have been developed, they have been affected by the computer architecture. Also, program design methodologies or new software development methodologies like object-oriented software development, which is leading to new programming paradigms by the extensions, by doing new programming language that has been created to take care of the new challenges. The well-known computer architecture is called von Neumann architecture, and also the imperative languages. Imperative language is a controllable language that are actually dominating or controlling, or they use what is called commands in order to execute specific actions. And those commands that have been developed in the language design are mostly affected by the development of the von Neumann computer architecture, in which you can see the data and programs stored in memory. Also, memory is separate from the CPU, which is central processing unit, because in the central processing unit you'll see arithmetical logical unit and also the memory. And also the instructions and data are piped from memory to computer CPU, so central processing unit. The basis for imperative language is variables model memory cells. So the variables are sitting in the memory locations or addresses. And also assignment statement modeling by piping, which is the assignment statements is usually a variable equal expression, or a single variable equal a value, as we will explain later. And also iteration is efficient. Iteration means looping or executing more than a statement more than one time or repeatedly. So the von Neumann architecture, as you could see, it's composed of the memory that stores both instructions and data. Also, the results of operations is that the instructions are going to the computer CPU, which is this part here, the CPU, which is central processing unit, composed of control unit and arithmetical and logical unit. The arithmetical and logical unit is responsible for mathematical computation, and control unit is the unit that controls the task or the performance of the ALU, arithmetical logical unit. This is through input and output devices, of course. Every time you input values, they will go to the memory, and then every time you the memory controls and finishes and did this result is going to go to the memory and then come back from the memory through the instructions and data and go back to the output device, as you will see here in this picture. Because input device takes the input from the keyboard or the mouse or any other input device, takes it to the CPU, in which it has control unit and arithmetical logical unit. The central processing unit that include control unit and arithmetical logical unit will exchange this information with memory unit, and then after processing is finished, is going to be taken to the output device as a ready application. So this is basically the von Neumann architecture. Why are we introducing the von Neumann architecture here? Because we would like to tell you that the von Neumann architecture of computer is the one that influenced the evolution of programming and design. This is just one example of the fetch execute cycle on a von Neumann architecture, in which you have a small pseudocode for initializing program counter, then repeating the instruction, then fetching the instruction by the counter, then incrementing means adding the counter, and adding the counter value, and then decoding the instructions, making statements, and then executing these instructions, and then end the loop or end the repeat. This is just part of von Neumann architecture example in a pseudocode. Programming methodologies influences this methodologies are influenced since early 1950s and early 1960s. In the early 1950s and 1960s, they were simple applications. People are not worrying about the perfection of application, rather than worrying about the machine efficiency, because machines are slow, memories are small, and programmers are not trained. So people worry about machine efficiency. They don't worry about the perfections or the quality of programs. But from back 1960s, people efficiency became important. The readability becomes important. Better control structure become important. People start talking about structured programming, using of structured programming, like using if statements, using loops, using switch statement, using structured programming constructs. Top-down design and stepwise refinement is important. By late 1970s, the process-oriented to data-oriented and data abstraction becoming more important, because people, they don't want to actually to write long programs. They want to write short programs that can do the job. By mid-1980s, object-oriented programming languages have been introduced. Data abstraction and inheritance and polymorphism has been introduced. And these concepts are object-oriented concepts. That means inheritance means you having a class inheriting the properties of another class. And also data abstraction, in which you don't really focus on the details. You focus on the main purpose of the program. to make your program smaller and more reliable and more efficient. We talk about structured versus unstructured programming. In this screenshot, you will see that the difference between structured and unstructured programming are very important. Like in a structured programming language, you will find the code is divided. What's called dividing the code means you don't put all the code in one single block. Also, you find functions or modules are used, and also easy to read programs and easy to change programs. There is no duplication for code and easy to test the program. But in unstructured program, all the code is just one in single block. People using programming paradigms instead of functions, very hard to read and difficult to change the code. So this is just a screenshot of the difference between unstructured and structured programming. And in unstructured programming, there is a lot of use of goto, because goto keyword will make you jump from one part to another, from one block to another. It's not like in sequence, where you would like, for example, you are in line 21, you can use go to line 122, which is going to skip all these lines and execute another line somewhere else in your code. So it is better to understand the difference between structured and unstructured programming. All object-oriented programming are using structured programming. The only unstructured programming that language that I have used so far is the basic programming language, before introduction of C programming language. In the language categories, which is, we can divide also these categories into 4 categories: imperative, functional, logic, and markup. Imperative, these general features that are using variables, assignment statements, and iteration, which is looping, if statements. They include languages like that support object-oriented programming languages and scripting languages, and also visual language like Visual plus and Visual Basic. Also C, example like that is C, Java, Perl, JavaScript, Visual Basic, .NET, C++, all these imperative languages. Another category that talks about functional or modular, in which the main means of making computation is by applying functions to given parameters. So you have to create functions and then execute this application through a lot of invoke of functions like Lisp and Scheme and modeling language and F#. All these are examples of functional or modular languages. In the logic category, what we call rule-based language, an example of that is Prolog. This is the logic programming category. So the rules are specified in no particular order. There is no order to specify your rules. They are arbitrary orders. So Prolog is an example of that logic programming language. And the last category is called markup category, or programming hybrid, which is the markup language that are extended to some programming languages like GSTL and XSLT. Also, these are markup languages. We can include also some markup language like HTML and XML and DXHTML. All these internet languages can be considered as markup programming hybrid. But there is a trade-off in the language design. Trade-off means what can we do versus what we cannot do. or if we do what, that actually stop us from doing what. In this case, we can divide this into three categories, which is reliability versus cost, readability versus writability, and writability versus reliability. In this context, we can say that reliability versus cost. How do you want programs to be reliable, and at the same time you want them to be cheap, not expensive? Like for example, Java demands all references to array elements to be checked for proper indexing, which lead to increased execution cost. I'm not talking about money here. The cost is the cost of execution, the cost of implementation, the cost of timing and performance and flexibility. This is the cost I'm talking about. So it's not about money. Here you want Java to refer to array elements, or these array elements to be checked for a proper indexing. This, if you do this will lead to increased execution cost. So also this can be compared between Java and C. This is C is low execution cost, but Java is high execution cost. Okay, another trade-off is between readability and writability. Readability versus writability. Okay, so example, APL provide many powerful operators and a large number of new symbols and new symbols in APL, but this will allow complex computation to be written in a compact program, and this is actually going to be at the cost of what? At the cost of poor readability. Yani you will have a lot of new symbols, but you will have your readability is very poor. And the last the last trade-off is between writability, which is flexibility, versus reliability. In like C++, for example, C++ pointers are very powerful and very flexible, but they are not reliable at all, and they can actually create a lot of issues and problems through the program processing. The last thing today I'm going to talk about is implementation methods, and there are three different methods that we can implement these languages: compilation, pure interpretation, and hybrid implementation systems. In compilation, programs are translated into machine language. This include GIT systems, for example. So compilation, to programs that use compilers in order to be implemented. And also in some large commercial application we use compilers. Pure interpretation we'll talk about programs that are interpreted by another programs by using interpreter program. So this example of drawing three different boxes, for example, red, blue, and green. These three boxes can be drawn like that using either compilation or interpretation. If we use compilation, then what happens is that you will start drawing them, draw the boxes, empty boxes, then you color them all, then you send the result all together. Like you're gonna see the three boxes at once on the screen, given to you at one single moment: red, blue, and green, if you use compilation. But if you use interpretation, then you're gonna do them like that. You draw the first box, and then you color it red. Then you go to the second one, you draw it, and then you color it blue. Then now you have two already finished. Then you go to the third one. You draw it first and then you color it as green. Now you have a third one. So there's two different ways to draw these boxes, using the compilation or interpretation. Also, there is hybrid implementation system, which is to compromise between compilers and pure interpreters. So you use small and medium system when efficiency is not the first concern for you. You can actually use a combination between compilation and pure interpretation in some languages, as we will explain in the next slides. So I will stop this video here and try to record another video, the second part in a different video. Thank you.